Welcome to Future Dr. Neet Academy for the problem solving session in NEET Physics. Topic chosen today is from chapter 7 of 11th standard, gravitation. And today is not problem solving session, problem questionnaire session. That is, 7 questions will be showered in this session, and next session we will solve the solution for this question. Let's move to question number 1. A geostationary satellite is orbiting the Earth at a height of 5 or above the surface of the Earth, or being the radius of the Earth. Time period of another satellite in our at a height of 2 or from the surface of the Earth is dash. A option 5, B option 10, C option 6 root 2, D option 6 root 2. And here you should know the formula for time period of a satellite, relation between the time period and radius, that is Kepler's third law. By using the Kepler's third law, you can find the solution for this question. Let's move to question number 2. A planet moving along an elliptical orbit is closest to the Sun at a distance r1 and farthest away from the Sun at a distance r2. If v1, v2 are the linear velocities at these points, then the ratio v1 by v2 is dash. Option A, r2 by r1. B option, r2 by r1 whole power 2. C option, r1 by r2. D option, r1 by r2 whole power 2. That is, here you should know the relationship between velocity, that is speed, and the distance. That is Kepler's law only. By applying Kepler's law only, you can solve this question. Let's move to question number 3. Two spheres of masses m and capital M are situated in air, and the gravitational force between them is F. The space around the masses is now filled with a liquid of specific gravity 3. The gravitational force will be dash. Option A, F by 3. B option, F by 9. C option, 3F. D option, just F. Here you should know the relation between gravitational force in air medium and this filled with some liquid medium. That based on the formula, you can find the solution for this question. Let's move to question number 4. The distances of two planets from the Sun are 10 power 13 and 10 power 12 meter. The ratio of time periods of these two planets is dash. A option 1 by root 10. B option 100. C option 10 into root 10. D option root 10. Here also you should know the relation between the distance and the time period. That is Kepler's third law. Applying that law only, you can solve this question. Let's move to question number 5. A body weighs 63 Newton on the surface of the Earth. What is the gravitational force on it at a height equal to half of the radius of the Earth? A option 28 Newton. B option 30 Newton. C option 24 Newton. D option 48 Newton. Here you should know the relation between gravitational force, weight, radius. By knowing the relationship only, you can solve this question. Let's move to question number 6. The acceleration due to gravity at height 1 kilometer above the Earth is same as that of the depth d below the surface of the Earth. Then A option d equal to 1 by 2 kilometer. B option d equal to 1 kilometer. C option d equal to 3 by 2 kilometer. D option d equal to 2 kilometer. Here you should know the formula for acceleration due to gravity with the depth, that is variation of depth. By knowing the formula only, you can find the solution for this question. Let's move to last question. The radii of circular orbits of two satellites A and B of the Earth are 4r and r respectively. If the speed of satellite A is 3v, then speed of satellite B will be dash. Option A 3v by 4. B option 6v. C option 12v. D option 3v by 2. Here you should know the relation between orbital speed or formula of the orbital speed, orbital velocity of the satellite. By knowing the formula only, you will solve this question. Okay, thank you students. In next session, we will see the solution for this question.